Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 5 for the April Daily LeetCode Challenge, and we have an easy question. This is the first time we are having easy question on this particular month. Yeah, there were one day where we are having the previous question, but again we did not solve it in the previous way. We solved it as a hard question. Okay, so the solution that I showed you, it was not for the easy one. It was actually for the medium level question that I showed you. Okay, that's why I'm calling this as the first easy question. Now, in this, if you see what we are doing, it is 1863 sum of all subset XOR totals. Okay, though they have mentioned the XOR keyword here, but it has nothing much to do with the bitwise XOR. I mean, like the concept is same, but again, here in this solution, the way that I have executed it and the way that it is expected, we are not doing any bit manipulation as such. Okay, we're directly using the XOR and we are getting the results. Okay, that's why I'm not going in detail of what is XOR. In my previous bit manipulation videos, I've done that already, but in this question, I'm not going in detail of XOR because it's not needed. You just need to know how to apply the XOR operator, and that is all you need for this question basically. Okay, now if you see this question, what you are given nums array, and the length of this is going to be up to 20. Okay, okay, sorry, not 20, up to 12. Okay, it is going to be up to 12. So what is happening is, if you see, you are given a integer array whose length is going to be 12. Okay, now what you have to do is you will have to take all possible subsets of this. Okay, remember they have clearly mentioned that even if the same subset appear with the same elements, then also you have to take it once again. Okay, as simple as that. So what is a subset? Basically, let us take some example and try to understand. For example, if you take example number 2, 5, 1 and 6, there are 3 elements. So there are going to be 2 raised to power 3. Okay, which is 2 raised to power 3 is 8. There are going to be 8 subsets as they have mentioned it here clearly. So you can go through each one of them. For example, 5 alone, 1 alone and 6 alone are going to be the subsets. Okay, and then other than that, we are going to have subset of 2 elements also, like 5 and 1, 1 and 6, and 5 and 6. Okay, something like this. And at last, we are also going to have subset of all the 3 elements. Okay, as simple as that. Or obviously, we are also going to have an empty subset. Okay, so here if you see, they are writing all the subsets, and now you have to do XOR of all the elements in particular subset. Okay, so the XOR of 5 with itself is 5. I mean to say, whenever there's one element, you have to write it as it is. Okay, whenever there are more than one element, you have to do the actual XOR. Okay, for example, 5 and 1, if you do XOR, are going to get 4. Similarly, for the other two, you have to do. And similarly, in this case, it is 5, 1 and 6. For all three of them, you have to do the XOR, and the answer is going to be 2. Okay, now whenever it is empty set, you have to, by default, you have to take the XOR result as 0. Now after taking all the possible subsets and taking all the XOR results, you have to add all the results, and finally you are going to get the answer. So all these results that you are seeing at 5, 1, 6, then 4, 3, 7, 2, all these things you have to add, and finally you are going to get the answer, just 28. You have to written 28 as your answer. Okay, so this is the question. I've given you one very detailed analysis of how the things are happening, what is actually subset, how it is coming. Okay, now the actual terms, if you see in the question, they are saying like, given an array of nums, return the sum of all XOR totals for every subset of nums. Okay, yeah, they've also given some definition. For example, if a subset with same element appears more than twice, see, we have to take it more than twice. Okay, as simple as that. It's not like only unique subset will be considered. Even if it is repeating one with the same element, it's still we have to consider it. Okay, as simple as that. Yeah, I guess that is all. Yeah, and zero. Yeah, that they have mentioned the definition of XOR total. They are saying that it's going to be a bit XOR of all the elements, and zero if the array is empty, right? So you can go through the question, okay, and let us try to see how it could be solved. Okay, one very important hint is that it has only 12. Okay, so let me delete this part. Basically, I took as 2 power 20. So like this is not correct in that case. See, 2 power 20, if you do, basically it is going to be equal to 10 power 6. So in total 10 power 6 calculation, we would have to do. But again, this is slightly wrong because I took 20. I should have taken 12. Okay, so the idea here is, if you try to solve it in a recursion, that is, I am trying to say the backtracking, because see, whenever you have to get the subset right, you will have to take the possibility. For example, see, in this case, if you talk about, there are three. Okay, now each one will have two possibilities here. Okay, whether this five could be taken or this five could not be taken. So there are two possibilities. Similarly, here also two possibilities. Here also two possibilities. So total, if you see all the possibilities, we are going to have 2 into 2 into 2, which is 2 into 2 raised to power 3. Okay. Similarly, for this particular thing, it will be 2 into 2 like that 12 times. So it will be 2 raised to power 12. Okay. So you have to add 2 raised to power 12, and then you have to compare with the 10 power, like which it is nearest to which 10 raised to power. Okay. So we have to compare that. I took 20 by mistake, but yeah, it should have been 12. Okay. So 10 2 power 12 will be even less. Okay. I guess it will be around 10 power 4 or 10 power 5. Okay. You have to take that. So again, because these numbers are very less, we can go for the actual, brute force implementation of it. So let us try to see how we can do the backtracking approach using recursion for this particular problem. Okay. First, challenge is to get the subsets, and second challenge is to basically, to calculate the XOR results and finally add the sum. So I've, this is the actual sum, but this is not a self-explanatory one. In order to explain how this is being done, what I've done is I've added some extra statements like the sets to actually show you how the results are coming. Okay. So if you see, for the example number, okay, this is the example number 2. Okay. For the example number 2, if you can see, these are the elements. Okay, and these are the way sets which are coming. First empty set, then all the sets, like single sets with 2 elements and sets with 3 elements. So that is how it will be coming. Okay. First, let us start to understand what is happening. I'm declaring a variable called answer. I'm capturing the length. Then I'm declaring a recursive function called a recursion. Okay, and this is the first call to the recursion. Okay, so this is the first call to the recursion, and yeah, this is the recursive function. Now let's see what is happening here. We're declaring the index I. Okay, this index will tell us currently which element we are going to process. Okay, as simple as that. And similarly, this will tell us the current XOR result. Okay, that is what is the current sum that we have. Okay, what is the current okay, it is not the sum, but yeah, actual XOR result that we have currently. Okay, for example, you see here, you have to do 2 XOR 5 XOR 6. Okay, so let us say we have currently only processed 2 and 5. So the result that we have value 2 XOR 5. If 6 comes next, so we have to again do XOR with 6. Okay, as simple as that. So I have declare these things as non-local because they are outside the scope of this particular function. And then what I'm checking, this is going to be the terminating condition for my recursion. Okay, so whenever I reach this condition, I have to terminate. What I have to do, if I is greater than equal to 1, then in that case, what I have to do is whatever XOR result I have, you have to add it to your answer and then you have to return. Okay. If this is not the case, then the return will not be executed and then we will proceed further. Okay. Now let us see what we're doing. Recursion of I plus 1, comma, current XOR result. Okay, recursion of I plus 1 comma current XOR result. Similarly here, recursion of I plus 1. See, the idea here is, as I mentioned, there are two possibilities for every number. Okay, whether this number will be taken for the current set or it will not be taken. So there are two possibilities. So we are going to have a separate recursion tree for both these possibilities. Okay, so if you see the first case, what we are doing in this case, we are basically not selecting the current number. Okay, if you see, we are just going to I plus 1, but the XOR result, that is the current XOR result, remains the same. In the other case, we are again going to I plus 1, but in this case the current XOR result is actually we are doing XOR of that with the nums of I. Okay, so this basically, when we go to the next iteration, actually the this particular value that we are going to add in the next iteration is basically going to be XOR of the previous value comma the nums of I. Okay, as simple as that. So this basically means we are actually taking the current number and doing the XOR. This means that we are simply going to the next number without doing XOR. So as I mentioned, there are going to two possibilities for every number, whether it will be part of the XOR, it will not be part of the XOR. So that is the way actually we are using to get all the possible subsets. Okay, well, let me give you one simple example. Okay, let us go to the example number one and let's see this. See, the idea is very simple. Let us say none of them were taken in the set. Okay, none of them are taken in the set. So we are going to get empty sets. Okay. Similarly, let's say only one of them were taken. Okay. So let's say for one we did not go for the set, and for three we include in the set. So we are only going to get three. Similarly, for one we included it, but for three we did not include. So it will be one. Okay. Similarly, for both one and three we can include. So it will be one and three. So that is how it will be done. For every number, basically there are two options. Okay, two options. Either we skip it or we include it. Okay. If we include it, we have to basically whatever XOR result we had previously, with that we have to XOR the current element also. Okay, as simple as that. And ultimately in the terminating condition, whenever I is greater than n, we are whatever result we had now, we are taking it and add it to our answer. Okay, finally once we are completing this function, we are coming back and returning the answer. Okay, as simple as that. So yep, and if you see, this is clearing all the test cases. I've already segmented this solution, as you can see. So yep, that was all for this particular video. This was more on the recursion side, and yeah, as simple. Yeah, it is up to 12. That's why it's always fine to go for a basic group approach. If you want to go for the optimized approach, which is the O of n approach, see, as I mentioned, the time complexity for this is going to be 2 raised to power n, and in this case it is going to be up to 2 raised to power 12. Okay, as simple as that. If you talk about the space complexity, see, the idea here is, in the worst case, what will happen? No, see, we are not using any data structure as such, right? But internally the stack space will be used. Okay, so the recursion, the way it is implemented in every environment basically is through the stack. Okay, so some stack space will be used, so you have to basically calculate how many basically how much is going to the depth of the recursion. Okay, at max. So in this case, if you see, for each element, in the worst case what will happen is each element will be selected. Okay, as we have seen here, right? So in the worst case what will happen is there are two elements, then all the two will be selected. So this is going to be the max depth a recursion can have. So yeah, it is going to n. Okay, so space complexity of this solution is going to be of n, and time complexity is going to be 2 raised to power n. Okay, as simple as that. So yep, and if you really going to want to go for the actual bit manipulation approach, okay, in which we are actually manipulating, that what to do is, I will give you the suggestion: take the results for all these things. Okay, try to see the bit version of this, and then try to see the pattern which is coming. That should be the way forward for it. Other than that, I don't see any other way in which we can do this. Okay, as simple as that. So yeah, that was all for this particular video. And see, for this kind of questions, what I can say is that it's all about how quickly you can implement it. Okay, believe me, this is what you have to see for this kind of questions. It's all about how quickly you implement, because the rank that you get in a contest will depend on how quickly you implement it. Because on a whole, see, ultimately, because the way the constraints are defined, okay, it is up to 12, right? Anyone can do this. Okay, anyone can do this if they see this constraint. So the idea is you have to do it as much quickly as possible, then you will have the best rank possible. Okay, so yeah, friend, that was all for this particular video. And if you like the efforts, if you like the solution, please subscribe to the channel. I've completed 165 days, and there are many more days to go. So if you like the efforts, please subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.